In most cases, ownership is clear. We know exactly which variable owns what value. But sometimes there are cases where a single value might have or need multiple owners. For example, the graph data struct. If we look in here, we see that we have multiple nodes of 0, 1, 2, 3, and 4. And then each of these nodes has an edge pointing to it. Well, node 0 is connected to node 1 and 4. So we can say logically that node 0 had multiple owners of 1 and 4. So for us to allow multiple ownership, we have RC, which stands for reference counted. RC is also allocated on the heap, and RC is going to track the number of references to evaluate whether or not a value is still in use. Naturally, if there are 0 references, then the value is cleaned up. As a side note, there is also ARC, which stands for atomic reference counting. It is the same thing as RC, but ARC is designed for safe sharing between threads. So only use ARC when sharing the pointer between threads, otherwise stick to RC. Now let's see an example of RC. So the first thing we need to do is actually bring it into scope. Use standard RC. Oh, that's because I left out. There we go. Alright, so now we have RC in scope. So now we'll say let S1 equals RC new, create a new reference counter, and then we'll say string from, and we'll just say pointer. And then to create references to our string, we'll say s1.clone, and then we can also clone s2 because it points to the same value on the heap. And then just to prove that they all point to the same value, we'll print them all out. We have S1, S2, and S3. And now if we run this, we see that we have pointer, 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 pointer printed out 3 times. So in this, we have an RC value pointed to a heap allocated string, which is going to have a reference count associated with it. Cloning an RC does not copy the value. It creates another pointer to it and increments the reference count. So again, in this example, the string pointer has a reference count of 3, and S1, S2, and S3, which are all on the stack, all point to the string that is located on the heap. And with our data being a string, we are still able to use string methods as usual directly. And I'll show this to you by saying S1 dot contains, and then in here we want to make sure it contains point. And then just to show that all the other ones are able to do it as well, we'll say contains in this one, and we'll say ter. So we would expect our output to now be true, pointer, and true. And we have true, pointer, true, which is what we anticipated. And that's really, again, all there is to it, to RC and ARC. So now in the next lecture, we're going to talk about ref cell.